Okay, so welcome back. Now we're going to talk about some special triangles that come up that you're going to want to know. Okay, first one is what we call a 30, 60, 90 triangle. Okay, now both of these, it's the ratio of the sides that are always going to be the same. Okay, and these I'm going to go by a unit, what we call saying that the smallest side is 1. Okay, so this is based on what we call a unit circle, but that's beyond the scope of this class. But what we're going to do is we're going to assume that the smallest side is 1. Okay, when we develop these. Okay, and same thing with this one here. So this is a 45, 45, 90 triangle. Okay, this is what we call the 30, 60, 90 triangle. Both of these triangles come up quite a bit, and they're special in the fact that, again, they have the same ratio of sides anytime you have this. It doesn't matter the length of the sides, the ratio will always be reduced to this. Okay? So for a 30, 60, 90 triangle, if we say that the side across from the smallest angle, which is the smallest side, is 1. And so we'll make these both 1 since they are the same, right? 45 and 45, so it's an isosceles triangle, right? So this is 1 and this is 1. So what happens? Well, if this is 1, then what happens to the rest of these sides is that this is going to be 1, this is going to be the square root of 3, and this is going to be 2. And this is going to be the square root of 2. And this one you can show by just using the Pythagorean theorem. Okay? Now, this is always the case, right? No matter what the side lengths are, okay? For example, if this is 5, right? Then this one would be 5 times the square root of 3, and this one would be 10, right? Or if this angle is 10, then we know this is going to be 10 times the square root of 3, and this is going to be 20. So again, if you know you have a 30, 60, 90 triangle, guess what? You know it's going to have this relationship, if you will. Okay, and also with this one, same goes with the 45, 45, 90 triangle. Okay, if this length is 3, and then if it's a 45, 45, 90 triangle, and I know this is length 3, then I know this one has to be length 3, and this one has to be 3 times the square root of 2. Okay, or if the length of this side is 10, then I know this side also has to be 10, and this side has to be 10 times the square root of 2. So again, I'm using the very smallest unit for these. Because if you know these, then you can find, this is true for any 45, 45 triangle, this is true for any 30, 60, 90 triangle. If you know you're dealing with one of these 2 types of triangles, then you know these 3 sides automatically, okay? And you can also, you know the relationship, in other words, okay? And there are other special triangles out there too, okay? Like the 3, 4, 5 triangle. Oops. Okay? 3, 4, 5 triangle is a triangle that has 3, 4, 5. Notice the hypotenuse is always the longest side, right? It's across from the largest angle. Okay? And this is also a 45, or excuse me, this is also a right triangle. Okay? We call that a Pythagorean triple. Okay? There's more, that's not the only one. There's a whole bunch of them. Okay? Okay, now let's get some examples and see how this works.